Welcome back to ArmanisMath. Today we're going to focus on reviewing some basic trig functions, also angle rotations, and towards the end a little bit of unit circle. So gear up for a kind of a solid review here for topic 7 basically. Alright, first thing I want to start with is for you to tell me in the chat or the live stream comments or the private chat or the camera, tell me Sohcahtoa. Help me with Sohcahtoa. What is Sohcahtoa? Is this not answering? Okay, I need more of us to participate. I need all of us to participate. Today is your day to shine. Sohcahtoa. Sohcahtoa is a mnemonic that we use to remind us of the trig functions, the ratios, and the trig definitions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sohcahtoa. So I will start by mentioning a few things. The first one, we're gonna go over all 6 trig functions. I don't think there's a Sohcahtoa for cosecant, secant, and cotangent, but it's very easy to get the other 3 trig functions. So the basic ones that we're going to look at is sine, sine theta. And now you might ask me, what is this theta? Where is this theta? Well, you have to decide where you put the theta. So, or it's either given you or given to you, or you have to decide. So I'm going to just put here for me. I'm just going to put this dude here. Sine of theta is going to be let's put some numbers here. 3 and 4 is going to be opposite over hypotenuse. And then you pause a second. Hold on, Armani. Well, there is no hypotenuse that we know. Well, there is no value here. Well, that means you have to come up with that value. So how do we come up with the value for the hypotenuse? Does anybody remember? How do you come up with the value of a hypotenuse? I will do it here on the side. How do you come up with the value for the hypotenuse? By the way, you could send this link to anybody else, even outside school. That would be awesome for them if they need a review. Use the theorem. I like that. What kind of theorem we're talking about? The Pythagorean Theorem. That's it. So because these are the sides, you could make this A, make this B, doesn't matter, but obviously C has to be C. C for the hypotenuse cannot be switched with any other ones. These two you could if you'd like. A here, B there, it doesn't matter. So I'm just going to say this is A equals that. And this dude equals B here. So we know that C squared equals A squared plus B squared. Keep doing that with me, guys. Let me know what you guys get. Let me give you a few seconds, maybe a minute. I shouldn't take a minute, but tell me what you're gonna get once you finish with this one. Give yourself, I'm gonna actually put a timer here for you. So we're gonna start timing ourselves today as if we're reviewing, actually as if we're taking the test or the quiz. So let's put a minute here for this dude here, and tell me once you finish. You could start writing the sign in the chat. As I said, there's all in the camera or in the live stream as well. All right. Perhaps remind. All right. All right. What you guys got? Anybody has some help for me here? Any numbers? Start putting your answers, you guys. Okay, I see a proposed answer here. Somebody see if you guys agree or disagree. Do you have a different input on this? So c squared is going to be a squared, which to me is 4 squared, plus the other guy's 3 squared. We're talking about a square root of, I'm sorry, a little bit, 16 plus 9. C squared equals 25. C equals obviously the square root of 25, which is 5. Good. So I'll come here and put 5. C is going to equal to 5. You don't have to have C's and B's anymore. That was just for you to plug into the Pythagorean Theorem. All right, let's play with some numbers now. So what is opposite of me? Well, again, you've got to know where you're at. You have to know where you're at. So right now, this is me. I am theta. I am theta. I am the theta. So basically, I am here looking. That's my eyes. That's my eyelashes here. I'm looking. This is me. That's my perspective. This is theta. So what is opposite of me? Can somebody tell me what's opposite of me? Let's focus, you guys. What's facing me? What's opposite of me? It is the 3. I can't say 5. 5 is not opposite. 5 is the hypotenuse. I can't say 4. 4 is not opposite. 4 is adjacent. That's right next to me. So for this one, it's going to be opposite, which is 3. Again, this is me. This is my eyes. I'm looking like this. This is opposite of me, divided by the hypotenuse. Can I put the 4 as hypotenuse? Is 4 a hypotenuse? No, 4 is not a hypotenuse. Hypotenuse is just its very unique thing, and it always faces 90-degree angle. Always like that. So the hypotenuse is also always going to be here. Just like this. It's like something of its own. It's got a mind of its own. That's 3 divided by, and the hypotenuse is 5. Okay, let's do the next one. The next one is going to be cosine. Cosine theta. Well, what's the definition of cosine? You go back to Sohcahtoa. What's the definition of cosine? You got, I need to see multiple users are typing. When you ask questions, make sure that you type sure that you share your thoughts. Make sure that you have multiple users are typing. Yeah. Multiple users are typing. Here we go. Adjacent over that, and I have adjacent over hypotenuse. And my adjacent is going to be the 4, right? The 4 over the 5. And let's do the last one, TOA, tangent. Tangent theta is going to be opposite over what? Over adjacent. Thank you. And to me, these guys are what? What's opposite of me? Wait, we just talked about that. 3 is opposite of you. Adjacent of you is 4. Okay. We're not done because there actually are 6 different trig functions. These are the basic ones. The sine, the cosine, the tangent. But there are some cousins in the family. Each one has a cousin. Each one of these has a cousin. So let's talk about the cousins a little bit. Okay, cousins. Oh yeah, cousins. So for example, the sine has a cousin and starts with a k. There's only one k for the pair. So the cosine has a sine has a cousin which is cosecant. And the good thing about this is you already have done the hard work. All what you do for these guys coming up now is to do the reciprocal of what you see here. For example, I know for sure that sine is the reciprocal of cosecant, which means I just have to flip this thing here. Instead of opposite over hypotenuse, becomes hypotenuse over opposite. Or just switch these. That's what you do. This one becomes at the top, and this one goes down. That's all what you do. Or you could do 1 over, obviously. So that becomes 5 over 3. This is the cosecant. This is the cosecant. The second one. Cosine has a cousin, and the cousin is secant. Secant theta. That's going to equal to, the definition of secant is going to be the hypotenuse over adjacent. It's just the opposite of this. You flip it. You do 1 over that. So that's like the secant is actually 1 over cosine, and vice versa. Cosine is 1 over secant as well. So basically just do the reciprocal of these, and you should be fine. Equals, and can somebody give me the secant? Can somebody give me a secant? Five over 4. Yep. 5 over 4. And one last one. Cotangent is tangent's cousin, and again it's the reciprocal of, or 1 divided by the tangent. And this is going to be adjacent over opposite, which to me is what? What is our cotangent here? Got 4 over 3. Okay, so in a nutshell, out of a simple triangle, I was able to come up with all 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And again, just a reminder that these pairs here, when they this is watch this for a second. This is a sine as a cousin of secant. There's only one k in the pair. This is cosine, so it has to match with secant. Yep, that's one way to remember that. And tangent is tangent. There's only one k in the pair. One k in the pair. Okay, quick check on your understanding. Check CFU, check for your understanding. Give me a true if you're doing fabulous, meaning you could actually explain this to somebody else. If you have a question like this, I'm not just going to be able to do it, I'll be able to explain it to somebody else. If false, that means yeah, but maybe one more example would help. Go ahead. Tell me what's going on. I am reading the feedback as I'm checking for understanding as I'm reading your responses to the poll here. I haven't heard from some of you yet. So Tatiana, Ryan, Olivia, Myra, Elijah, Donovan, Devin, David, and Alexia. Alright, so waiting for more. I am waiting for more. So just remember, I'm waiting. While I'm waiting, I'm going to just go over this one here again. Sohcahtoa helps us to remember sine, cosine, and tangent. The definition. Definition means what exactly are you doing? What's the ratio? The ratio is from the opposite divided by the hypotenuse, adjacent over hypotenuse, and finally the tangent is opposite over adjacent. I know that this is basically the reciprocal of that will give me the other three functions. So the reciprocal of sine is cosecant, reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Reminding myself there's only one c in the pair. One c in the pair. Meaning you can't have a reciprocal of sine with the secant. You have to have a cosecant with cosine with cosecant. Nope, that's two cos. You only have one co in the pair. There's only one co in the pair. Okay, I do see that from what I'm gathering here that you would probably need one more example, which is totally fine. We're gonna do one right now. What? Right now we're gonna do one. Are you sure, Armani? Yes. Let's take another look, and I'm gonna give you this example or equation. By the way, these little triangles, we call them tiny but mighty. I've been in a restaurant where they show some black beans as tiny but mighty. Well, that's what we're talking about. Tiny but mighty. Here we go. This question goes like this. Given, by the way, this is number 2, example 2. Given cosine of theta equals 5/13, write the other 5 trigonometric ratios. Okay, so basically they give you one and they ask you to do the others, to come up with the other. As I always recommend you, you probably need to put, once again, you need to put tiny mighty triangles just for your eyes to see. It looks like there's a 13 here, and I have to know the definition of cosine. What's the definition of cosine again? What's the definition of cosine? The definition of cosine, like cosine from Sohcahtoa. Yep, here we go. Adjacent over there. So it might not look drawn to scale, but that's what I've got here. Okay. Adjacent over hypotenuse. So I'm going to put the adjacent here just for the sake of 5 here. Hypotenuse is 13. In this case, I really have to be careful where did I put my my theta. I chose that little one here, right? If this is a little one, well, then the theta is going to be at the top here. That's my theta. So I put the theta at the top here. And I'm waiting for this dude down here, and obviously this dude is a side. It's not a hypotenuse because of this here. The definition of cosine is adjacent over hypotenuse. So I know this is adjacent. Maybe I could write this right next to it. Adjacent, and I know this guy is a hypotenuse. Excuse me. So I just label that here, and I'm waiting for this side. So I don't know how much is this side. Maybe you want to call it a B or A. It doesn't matter. So maybe I could call it a B. Equals something. I'm not sure about that number. Okay. So first thing first, to come up with a value for the B, I have to do what? Somebody help me out. Why don't I actually give you also a timer here? So get yourself about a minute for this B. And tell me once you're done. Keep going, Giovanni. Keep going. That's good. All right, let me pause here. Any hope here? Did anybody come up with the extra number? Lindsay, any hope there? David? Brianna? Anytime you are, I mean, I hope that that's what you're doing, because if I'm allowing you time to do it and make mistakes here, this is the time to practice. So you are missing out. I mean, obviously I could put it here. It's gonna spoil the learning because you need to do it yourself, right? In math, you gotta do stuff on your own. You got to solve on your own. You got to show work and stuff like that. So you're missing out if you're not using the time wisely here. Anyways, so I'm going to say a squared plus b squared equals c squared. And I'm looking for b, so I'm going to subtract the a from both sides. So basically I'm going to say this is b squared equals c squared minus a squared. But maybe this guy I'm going to label it as a. And obviously this is my c here, right? So that's what I'm looking for. Equals c. This is 13 squared. How much is 13 squared? Minus 5 squared. How much is 13 squared? $169 minus 25. I've got myself how much? B squared equals how much? 144. If we know our basic multiplication table, what times itself gives you 144? Here we go. b equals the square root of 144. B equals 12. All right, 12. So I know this side is 12. Remember, you do the work on the side so you do not clutter your area of solution. Do this work on the side. So I got 12 here. So I'm going to go here and then actually put 12 next to this dude here. B equals 12. All right. You probably do not need C and A anymore. You could leave them, but it's up to you. Now let's do the 6 trig functions. Let's start with sine. So let's start with sine theta. Pay attention because theta is at the top right now. Pay attention because theta is at the top. And they're going to do that to you in the test. One time they're going to have a theta in the top, one time at the bottom. You just have to make sure that you're paying attention to your perspective here. Okay, champions. What's the definition of sine? You'll find me doing this over and over and over again. The definition. So actually, before I do that, I'm going to put Sohcahtoa here again. Can somebody help me with Sohcahtoa? Sine is opposite over hypotenuse. Cosine is cosine. Here we go. Adjacent over hypotenuse. And toa is tangent is opposite over adjacent. You've noticed that I'm writing this every single time I have problems with trig because I just wanted to make sure that I know this one. I would not forget. Repetition helps also with memorizing. That's one way to memorize stuff. Cosine. Alright, so definition of sine is opposite over hypotenuse. And why don't you guys give me some numbers for that? Cosine theta. Let me do the first one. I'll do the first one. Opposite of me divided by the hypotenuse. Well, I am here. Don't forget, you're here right now. Your eyes are here, meaning I am looking at this from this perspective. This is me here. See that? That's you at the top. So what's opposite of you? What's opposite of me here, if this is my eyes looking down? The 12 is. That's very true. Hypotenuse is 13. Okay, keep going. Give me the cosine and give me the tangent. Somebody has a 5 over, that's adjacent over hypotenuse. And somebody's telling me it's adjacent to view, which is this one here, right there. That's adjacent to me. It's not going to be the 13 because that's the hypotenuse. So 5 divided by 13. And lastly, tangent. Anybody for tangent? Any takers here? Going once, going twice, gone. There we go. Lindsay and Giovanni has that. Okay. So definition of tangent again is opposite over adjacent. And I see myself looking at opposite of me is 12. Adjacent is 5. 12 over 5. Right, let's get to the cousins. The cousins. Yes, they have cousins. It's a big family. What's the reciprocal of sine? What's the reciprocal of sine? Reciprocal means 1 divided by sine. No, what's the name of the function? What's the reciprocal of sine? Cosecant. Thank you. Cosecant theta. And it actually is just, you flip this. It becomes hypotenuse over opposite, which is 13 over 12. Okay, keep going. Who is, what's the reciprocal of cosine? Or like what's 1 over cosine? secant. You can't put cosecant because once again this has a co sign. You can't have another co here. There's only one co in the pair. And this one again, you just flip that. So instead of adjacent over hypotenuse becomes hypotenuse over adjacent, h over a. 13 over 5. And what's the reciprocal of tangent? Cotangent. And adjacent over opposite, which is 5 over 12. That's it. We're done with this. Yeah? Another quick check for understanding. By the way, I took these answers from you guys in your chat, so you guys helped me do that. Another quick poll here. True, if this is good, I'm kind of fine. I could actually explain this to somebody else. I could. If you gave me I could explain. You could give me tangent, cotangent, secant. I could explain this to somebody else. For anybody who says no, please help me with the private chat and tell me what's going on so I can try to address the need. Don't just brush it off and go. So please do that in the chat, or if you would like on the camera as well. Remember, this is your education. This is you. This is your grade. It's not your friend's grade. This is you. This is your learning for the future. You're building blocks here. So you've got to ask questions if you have questions. And you also need to respond to my poll. Ryan, Alton, Padilla, Juliana's, Elijah, Donovan, David, and Alexia. What is up with this? Okay. We gave you one for I basically give you this triangle first, and then from it we did 6 of them. This one I gave you cosine. If anybody else need help, you've got to tell me now before I move on, because it looks like from the poll we are moving on. So if you need any help, make sure that you tell me that in the either private chat or the poll here. All right. Okay, Alton. All right, guys. Giovanni, okay, I'm not sure if we could do something about that, but I am moving on. I'm moving on. The next item we're going to discuss is going to be some identities. We call them identities in math. So, for example, if I said sine theta, I could say trig identities. Sine theta equals 1 over cosecant. It's called reciprocal identity. 1 over cosecant. And we just show that with numbers. You guys remember that? We just showed that with numbers just a minute ago. Which also means, by the way, that cosecant theta is 1 over sine theta. Oh wow, how is that done? Well, you could just put this one as 1, cross multiply, right? That's gonna give you a, you don't have to do it, I'm just showing you why. Cosecant theta sine theta equals 1. I just cross multiplied here, like this, and like that. And then you're gonna divide by sine theta, divide by sine theta. So voila, that's what you get. Cosecant is also 1 over sine. That's why they're called reciprocal identities. Reciprocal identities. Okay, so keep that in mind as you're thinking. You did the math a minute ago. You did the numbers a minute ago. Let me show you. We did that here with the numbers. So why is that true? Well, we just showed you why. It's because these guys are reciprocal identities. So we go backwards here. And now cosine. Can somebody tell me what I'm going to write here? Cosine equals what? Somebody tell me. 1 over what? 1 over secant. That's very true. Which also means that secant theta is what? Somebody tell me. What is secant theta? Lexia, are you here? Brianna, David. Come on, you guys. You can't just keep calling your names, or you just like me to call your names. Like, hey, he's calling my name. Oh, wow. Elijah, Emmanuel, Juliana's. Ay. Kennedy, Kira, Maddie. 1 over. No, yes, I got that one, but now I'm talking about secant is 1 over what? Secant is 1 over what? It's here, it's here. Just look. Just look. It's going to tell you exactly what's going on. Yep, simple as that. Remember, cosine is 1 over secant. Secant is 1 over cosine. Well, what we're saying here is these two guys are reciprocal identities. So just one divided by the other should give you the first one. Okay, tangent theta equals 1 over what? One over cotan. I am pleased with those who are participating. Guess what? You are practicing some test questions right now. Believe it or not. Okay, here we go. How about cotangent theta? And remember, in here you share thoughts. Doesn't have to be correct answers. 1 divided by or 1 over tangent, or the reciprocal of tan. Okay. And can somebody tell me, finish this statement for me. There is one blank in the pair. What is that? Blank. Fill in the blank. Those who take notes, I had it. This is when I need to see multiple users are typing. You are competing to put the answer. Here we go. And I just saw that. Multiple users are typing. Oh my gosh, this is nice. Oh my gosh. Oh, my eyes. My eyes can't even. Wow, I can't even fathom. Well, let me fathom. And then nobody's typing that. Ah ha 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 ha. Come on. A lot of you were typing now. What happened? Is this a chat delay or something else? Fill in the blank. What is it? There is one something. One something. What is that something? What's that blank? Nice try. Those will take good notes. Actually, the first one will come up with this one will have an extra credit immediately on the grade book. Not even it's immediately gonna go to that. And that goes here. Or that goes here. Okay, did anybody come up with that? Let's check. Nope, not yet. Nope. There's only one in the pair. Getting closer. Alright. Olivia. Olivia got it. There's only one co in the pair. Remember? Sine and co. Sine and cosecant. I just said that, you guys. Where were you? Cosine and secant. There's only one co in the pair. You can't have cosine and cosecant. Tangent and cotangent. There's only one co in the pair. 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 Moving on. Hold on. Before I move on, where is Miss Olivia? Olivia. Where is Miss Olivia? It's over here. Alright. Oh, no wonder. 1 second. Oh, Lord have mercy. Let's go here and check this one out. Yep. Alright. Next item, we're going to go to 7.2. Reviewing 7.2. Perhaps this would be more fitting. And in 7.2, angles. We're going to review angles, okay? So I would like you to know, you probably already know that, but to start graphing, let me choose a thinner color. Oh, actually, hold on a second. I should do here. Let me put at least 3 of these here. 1. There's 2. Here is 1. There's 2. There's another third one. And here is 2. Right, I want to start graphing things here. So, and you start graphing angles by having something called initial side. Where do you start? That's your initial side. So I'm going to start here, initial side. Initial side is on top of the x-axis. Initial. And we all know that the default rotation is counterclockwise, against the clock. So apparently some of you did not maybe look at analog clocks, which is fine, but you go like this. That's counterclockwise. That's the default rotation. And that's the positive rotation. So positive rotation is counterclockwise, against the clock. So now let's say I want to graph I'm going to say I want to graph 45. Okay, so 45 degrees here. 45. And I rotated, if you paid attention, I went this way, like this. Again, positive. Counterclockwise, against the clock, positive. And I land on this terminal side. So you might want to also label that, because that might show up as a definition or something. This one's called terminal side. Terminal. Okay, terminal side. Now, if I wanted to keep rotating, so I'm going to take this terminal side and then maybe put it here. That's going to be 90. Here, 180. Here, 270. Here again, 360. But if I added 360 to 45, I'm going to land on the same spot again. What is he trying to say? What I'm trying to say is these yellow dots here are going to be filled with coterminal angles. Coterminal angles means angles live in the same terminal, just like roommates. Like they co-inhabit the same terminal. So sometimes they have positive roommates, sometimes they have negative roommates. Hopefully you might want to stay at home during college. You're going to avoid either of them. Particularly the negative roommates. But anyways, this is what I'm trying to say here. If you want to get another angle on top of the 45 that lives exactly on the same spot here, so I'm going to go and rotate again, and let me use this color. I'm going to use actually the black color. So I'll take here, I'm going to add another 360 to that dude. So I'm going to go down here and put, somebody find this for us, 45 plus 360. Can somebody find us, what's that number? Does it take that long? Wow. 405. Thank you, Myra. 405 lives here as well. So 45 lives here and 405 lives here. Wow. Yep. It lives in the same spot. Same apartment. Or same house. Can I keep doing this? Yeah, of course. Keep looping until you get dizzy. You keep adding 360, which is full rotation, right? 360 is full rotation. So you keep adding, and then you're gonna land on the same spot. Okay, so now let me think about this. What if I wanted a negative roommate? Negative roommate? Yeah, you're gonna have some of them if that's what you end up doing. 45, and all what you do is actually subtract. You subtract 360 from it. You're gonna land on the same spot, but you're gonna have a negative roommate. So somebody find this out for us. What is 45 minus 360? Negative 315. That's very interesting. I'm gonna change color here. Negative 315. How did you get that? Well, I start rotating from here, and remember, this is negative. So you're gonna go this side. Basically, you're gonna go here, and you're gonna say, oh, okay, I'm gonna start rotating clockwise. That's negative. Clockwise, that's negative until you get here. And you're gonna live with these guys. Yeah, which is negative 315. So it depends on how you rotate. You could end up with positive, you could end up with negative. So your initial angle could have multiple, actually infinite number of angles, which we call them coterminal, on the same terminal side, just depending on how many times you want to loop. Maybe I want to loop twice. Sure. Take this guy minus 360, again minus another 360. You find yourself looking at another angle that is a negative, which lives here as well. Okay, another one I want to mention is, let's say I wanted to graph, and now we have more knowledge of what I'm talking about. So where do you think is 135 would land? The first, the second, the third, or fourth quadrant? 135. Which quadrant is 135? Let me put this here, and I'll give you this here. This is quadrants. Quadrant 1. Quadrant 2, you guys remember that, right? From your circle. Quadrant 3. and the quadrant 4. Okay. Where does 135 live? 135. One huh? One who? 135 degrees. Where does it live? 135 degrees. Quadrant 4. Interesting. Quadrant 4. Okay. If I passed this guy already, that's 90. That's 180. This I already passed what I want, by the way. This is a third quadrant, that's 270. Which quadrant is 135? 135. In which quadrant is 135? Can somebody help here? See if Giovanni is in the right place or not. Do you agree or disagree? Where is 135? Champions. Which quadrant is 135? Appropriate words, word choice, Giovanni, word choice. Second, I see second here, which is true, by the way. Because if you pass, this is 90, if you just think of passing here, this guy's going to say, why? Well, this is 180. You're passing 180 here. Remember, from 0 to 180. Remember that? So you can't pass the second. You're actually in the second. So basically you have 135 is in the second quadrant. Second quadrant. Okay, well, based on that, where do you guys think I have the following angle? Let's say I have 260. Where's 260? First, second, third, or fourth? Hello, 260. Oh, I got 0. 0 degrees. 90 degrees. 180 degrees. And 270 degrees. So 135 is in the second quadrant. We said 260, right? 260 would be 1, 2. Yeah, you're right. It would be here. It has to be less than 270, right? So it has to be in the third quadrant. Now, what if I want to kind of tweak things a little bit? What if I said, find me the quadrant that I've got negative? Be careful now. Negative. And let's say I have 240. Which quadrant is negative 240? Joseph, I see Joseph typing. Which quadrant is negative 240, not positive 240? So, be careful. There's a trick here. Is it? Is it the first? Is it the second? Is it the third? Is it the fourth? Which one would it be? 240. 240. Well, let's take a look. I could start 240 here. Again, you always start here. This is your initial. That's not going to change. And now it depends on the direction. Do you think I'm going to go counterclockwise at the top or bottom clockwise? Which one do you think? If it's counterclockwise, somebody talk to let's do this. Can I go like this? Can I rotate like this? Yeah? Is that right? Or do I rotate in the other direction? Because of the negative, you actually rotate in the other direction, which is with the clock. Okay, So I'll rotate with the clock. Rotate with me here. Don't get dizzy, okay? Come on. Here we go. Here is, how much is this now? What's the line I'm crossing right now? What's the degree here? Slow down. I think you had that one on... whoa. Take it easy. What's this one here? Kennedy, what's this one here? Yeah, but remember, if you're doing it in the negative direction, you start counting from 0. So this is 0, and then this is going to be negative 90. Wow, Armani. Yes, it's true, because now you are moving clockwise. So you're counting from 0. 0, and then you're going to get negative 90. Wow. Keep counting a negative here. Negative what? Which one is this one here? If this is going to be negative 90, because I'm going clockwise, what's going to be my next hop? Exactly. Is it positive or is it negative, Brianna? Remember, you're going this way. You're going this way. It is negative. Now we have negative 180. Okay? How much do we need? We need 240. So can I go here? Can I cross this dude? It's negative 90, negative 180. I need 240. Well, if I go all the way to here and get to this guy, he's going to complain because it's saying, this is 270. It's negative 270. That's way too big. I only need negative 240. So I have to back up a little bit here. Back up a little. Okay? Back up a little. And then where do you think I'm going to land? Over here. That's it. I have to stop here. No, don't say that, Giovanni. I gotta stop here. I like it because you participate and you definitely your brain is working. So you're trying. I'm gonna stop here. So negative 240 is in which quadrant? It's second. Yeah. Remember, even if you, by the way, the quadrants do not change. The labels here do not change. So this is always going to be first, second, third, and fourth. Regardless if you moved in clockwise or counterclockwise, the labels for the quadrants does not change. So given that, I'm actually going to land on the second, in the second quadrant. Okay, second quadrant. Okay, let's do a quick check for understanding here, which I have been doing, but let's do one more. Give me A. A means you're doing fabulous. B means, yeah, but maybe more practice. C is I am clueless. What is this? Doesn't look like a video game that I play. That's just way different. Shalom and Kayera, Joseph, Giovanni, Emmanuel, and Elijah, Donovan, David, and Alexia again. Give me your opinion. A means I'm fabulous. I actually could explain this to somebody. If you give me a problem right now, I could explain to somebody else. B means, yeah, but, yeah, maybe with a little help, maybe with more examples. C, I don't know. What am I doing? I'm just rotating. I got dizzy. Rotating. All right, what does that mean? How about the rest of you? Okay, based on what I've seen thus far from this poll is we need more examples. So let's do that. Let's do 3 more examples, not just one. But I actually need you to, you guys, whoever asked and said no, I'm not sure, okay, maybe one more example. You've got to do something, right? So if I give you examples, do it. Do them. Here we go. We're gonna go with 3 other examples. Here's 1. And here's 2. And here is the 3rd. All right, and this one is going to be draw, or where is after you draw it, obviously, where is negative where's negative 90? Okay. Or draw, basically I'm just asking to draw negative 90. And this one is going to be I need a coterminal, another angle of this one I'm gonna go with 120. I need a coterminal, another terminal, another angle that lives in the same spot as this dude. And the last one is I need you to find where is negative 300. Where is negative 300? Where is it? Is in what quadrant? Okay. So let's go back to you guys and start sharing some thoughts. How do you think I could graph? What's the first thing I need to graph when I graph this these angles? What's the first thing that I need to start with? What's the first thing I start with? Come on, you guys, you asked for this, so help me out. A little bit closer. What's the first thing that I draw when I want to draw this angle? What's the first thing that I start with? Okay, let's take a look at the notebook. Awesome, guys. What do you think I start with? What's the black line that I always start with when I graph? Well, let me give you a timer. I'm gonna give you a timer. Let's do yeah, 1 minute's fine. Do not lose the minute. Do not waste the minute. Look at you, flip through, flip back to in your notebook and see how you're gonna start graphing. And where would this negative 90 be? Graph negative 90. Where is negative 90? Find a coterminal for this thing. Okay. What's the first thing we need to graph? What's the first thing is, which if I were to give you a hint, it lives on top of some axis here. What is that thing called? I'll put that on top of the axis. What's that thing called? Does the word terminal ring a bell? You always start with the initial terminal. Okay, initial terminal. Basically, you live on top of the x-axis. And then somebody can tell me somebody, do I move clockwise? I'm sorry, clockwise down here or counterclockwise at the top? Which one do you think I'm going to move? This one or this one? I'm going to move clockwise. How far should I go? Well, you start from 0. You have 0. Okay, I have 0. 0 degrees is here. Then I move this way. This way is going to give you all the way to what? Where should I stop? Should I cross this here? Should I cross this? Should I go here? Should I cross? No! You don't cross. You're actually exactly on top of the line itself. You're actually here. So your terminal side, remember the initial and terminal side is going to be exactly here. That's going to be your terminal side. And that's going to be where the angle is. I've got negative 90 here. Next one. Let's do this one a little bit quicker here. Find the coterminal of 120. Okay, where is 120? Can somebody tell me where's 120? First, second, third, or fourth quadrant. Where's 120? Somebody tell me where is 120? First, second, third, or fourth quadrant. There's a 1, 2. There's 1, 2, 3. And there's fourth. 120 happens to be. I need more of you to participate, you guys. I'm being serious now. I need to see more of you participate. Focus. So I start with what? Does anybody tell me where do I start again? What's my starting point, or what starting line I should say? What's my starting line? Where do I start? What's that thing called? Terminal. That's there's two names for that. Either initial or terminal. Yep, initial. So I'm gonna start with that terminal. And then go, do you think I'm going to go clockwise or counterclockwise? Should I go up or should I go down? Counterclockwise against the clock, Armani. It's positive. That's positive. That means you go this way. All right, so I'm going to go this way. And then where do you think I'm going to land? Second, you said? Yes, it is second. Because that's 120, and I'm going to land on the second. So 120, which is, by the way, 60 away from here. 120 means I'm 60 away from this dude here. This is 120, which is 60 away from this guy. Now I need a coterminal. I need a positive roommate for this guy. So what do you think I'm going to do to add what to the 120 to get me the positive coterminal? Add how much to the 120 to get me the positive coterminal? $360. Got 120 plus 360. And how much is that number? 120 plus 360. 480. Okay. So you just have to know that 480 also lives here. So this guy here is 120. But again, another guy here is we just looked at that. That's 480. And if you want to rotate more, obviously do another 360, like twice as much, 3 times as much, or n times as much in both directions, by the way, positive or negative. Okay, the last one here is going to be this dude here, and this is negative 300. Where is negative 300? How do I graph this one? How do I graph this? What's my starting again? Where do I start? I gotta start with the initial terminal, just like this, on top of the x-axis. And then am I going up or down, or what is this here? Am I rotating to the left or to the right? Clockwise. Cool, right. Clockwise would mean here. Tell me when to stop. I passed negative 90. I passed negative what? This is negative 90 here. I passed negative 180. Thank you. I'll keep going. I passed negative what? I passed negative 270. That's this guy here. Which, by the way, is the same as 90. Don't forget that. The original guy is 90 here. This was like the first person who lived there. 90. But then there came these guys and they shared the same place with them. So where do you think I should I keep going? I'm looking for 300. Negative 300. Okay, I got that. So away from 360. So I'm 60 away from that dude. I'm 60 away from my x-axis. So I am here. Remember that you rotated this way, right? Where you rotated this way and this way. That's negative 300. So which quadrant is negative 300? Yep, exactly. It's in the first. In the first quadrant. And last thing I want to just mention here that pay attention to the angles when you graph them. Whatever takes you to the closest x-axis, we call that a reference angle. What does that mean? So for example, look at this one here, number 2. This is 1, this is 2, this is 3. In number 2, I wanted you to look at 120. What's left from the 120 to get to the closest x-axis? How much is left here? Can somebody tell me? What's left here to take you to the closest x-axis? How much is left? I'm calling on champions. How much left from the 120 to get me to the 180? That's my closest x-axis. How much left? 120. 120. 2. Here we go. Here we go. It is 60. So I just wanted to introduce this concept. Something here, this 60 is called the reference angle. Reference angle. So if you see them referring to something called, if you see them mentioning the word reference angle, that's what they're talking about. Whatever takes you to the closest x-axis, that's called the reference angle. So this is 60. How about this dude here? Can somebody tell me what's my reference angle here? Where's my reference angle? Remember, it's whatever takes you to the closest x-axis. Whatever takes you to the closest x-axis. Try it again, Joseph. I see you trying it here. Myra, Ryan, Shalom, Tati. Hello, champions. How much I need to get to the closest x-axis? I'm basically looking for this amount here. How much do I need to go to the closest x-axis? I see multiples user typing, so I'm gonna just give you a few seconds for that until I see something. Shut up, because multiples user typing. So what is that angle here that takes you from this terminal all the way to that closest x-axis? What is this here? How much is that? Look at what you got, you guys. Look at what you got here. You've got negative 300, right? That should tell you something. What's the total? What's the total in one rotation? What's a total angle in one rotation? What's a full revolution around the circle? Aha! Aha! That's very true, because you have a full rotation, a full revolution, when you have 360. But you're only given 300 of it. So what's left? What do you guys think? What's left? Myra says it's 60, and she's right. 60 is my reference angle. Is it always like that? No, it's not like that. What if this angle was what if this angle was 315? What do you think is going to be the reference angle? What if this was negative 315? What do you think is going to be the reference angle for that? Champions! If it's 315, then you're going to land where? How much do you need to get to 360? Hello? Yes, 45. That is true. It will be 45. The reference angle to be 45. By the way, the reference angle is always positive. Just keep that in mind. Reference angle is always positive. Okay? I believe this should suffice for today. You guys have done an awesome job. And I shall see you next time. Until I see you then, be blessed.